So if you want to graph a quadratic inequality, there's just a couple of things that you need. The first thing would be the vertex, and then the second thing would be either the y-intercept and the x-intercept, or you could use the key points. And the key points are going to be 0, 0, 1, 1, and 2, 4, and 3, 9, just like they were when we were talking about graphing quadratics, not inequalities. So if you had one, for example, like y is greater than x squared plus 2x minus 8, the first thing you need to be able to find is your vertex. So to find your vertex, we're going to do x is equal to negative b over 2a. So your a here would be 1, your b would be 2, and your c would be negative 8. So we're going to plug those things in, and we're going to say negative 2 over 2 times 1, which is going to give us negative 1. And the way that we get the y value that goes with that is by taking that negative 1 and plugging it in for all of the x's. So negative 1 squared plus 2 times negative 1 minus 8. So 1 minus 2 minus 8, which is going to give us 1 minus 10, or negative 9. So we're going to go to the point negative 1, negative 9, and that's going to be our vertex for this inequality. Now, like I said, we can either use the key points or the x and y intercepts. So for this one, we'll just go ahead and find the x and y intercepts here. So if you needed to find your y-intercept, you need to just plug in 0 for all of the x's. So we're going to have the point 0, comma, if we plugged in 0 into this one, we're going to have 0 plus 0 minus 8, so that'll give us minus 8. So there is our y-intercept. And the last thing, to find our x-intercepts, we want to factor if we can. So we're going to check to see if this one factors. If not, we're going to have to use either the quadratic formula or the completing the square method. So we check to see if it factors. We break up x squared into x and x. We break up negative 8 in a way that is going to combine to be 2x when we check the outer and the inner multiplication. So we want to get factors of 8 that are going to subtract, since this is a negative sign. So if we wanted to subtract, that means one of these is a plus and one is a minus. We need factors of 8 that subtract to give us 2. That's going to be 4 and 2. And the 4 needs to be positive, so that when we say negative 2x plus 4x, we come out with a positive 2x, which is what's in green up here. That's a positive 2x, and so is this. So we have the way that it factors. To get the actual x-intercepts, we're going to set each factor equal to 0. So we have x equals 2, x equals negative 4. So our points are 2, 0, or negative 4, 0. Those are the coordinates here for our x-intercepts. And we know that the axis of symmetry is the line that goes through the vertex, so we can take this point and reflect it to the other side. And when we look at our original equation, it was a strictly greater than. There's no equals to, so we're going to be using a dotted line here. So we've got our dotted line in here. And now the question is, where do we shade? So to determine where to shade, we look at this right here. It says y is greater. So if you put your pencil on your vertex, you want to know this y value down here is negative 9. You want to know which way should we go to find y values that are bigger than negative 9. And that would be up. So we're going to shade on the inside of our parabola. And so this would be what our finished solution would look like. Now, if you have a system of inequalities, that means that you're doing the same process, but now you have two inequalities that belong on the same coordinate plane. So we have y is less than or equal to negative x squared plus 4. And we're also going to add to that y is greater than x squared minus 2x minus 3. And so for the first one, we're going to start out the same way, and we're going to find the vertex. So we'll do all the work for the first one in black because that's the color that's on here right now. So we'll find the vertex of the first one, and we're going to do that the same way we did last time, using negative b over 2a. So we're going to, if we look up here, you can see that b from ax squared plus bx plus c, b is always what's found in front of the x term. So when we look at this first one, our a is negative 1, our b, we don't have an x term, so our b is 0, and our c is 4. So when we plug this in, we're going to have 0 over 2 times negative 1. And 0 divided by anything will still be 0. And so when we find the other part of our vertex, we're going to take that 0 and plug it in. So 0 squared is 0 plus 4 is 4. And that's also going to be our y-intercept. So our y-intercept is also 0, 4. But this time, instead of finding the x-intercepts, let's go over how to use those key points. So the key points are always going to be 0, 0, 1, 1, and 2, 4, and 3, 9 if it will fit. But you're going to take the y values and scale them by the scale factor. And the scale factor is the a value. So we're going to multiply those y values by a to give us 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. Now, if we're going to plot this graph, we're going to start with the vertex. So we go to 0, 4. And then we're going to plot the key points as if this point were 0, 0. So it's not really 0, 0, but for our purposes, we're going to pretend that it is. So we've plotted 0, 0. Then we're going to plot the point 1, negative 1, 2, negative 4, and 3, negative 9. And we repeat that on the other side. And since it's a less than or equal to, we're going to use a solid line here. And it's a less than, so we put our pencil at the vertex, and we determine that we should be shading below, which puts us inside our parabola. So we'll just use that arrow for right now, and we will graph the other inequality. So we have to find our vertex, which is going to be given by negative b over 2a. So positive 2 over 2 times 1, which is 1. And when we plug 1 in, we're going to have 1 squared minus 2 times 1 minus 3. So 1 minus 2 minus 3 will give us negative 4. So we're going to be at the point 1, negative 4. So if we go to 1, negative 4, there's our vertex. And so we can either factor or we can use the key points again. Since we used the key points last time, we may as well just factor this one if it will factor. We can use the y-intercept. We plug in 0 for x to find that. So that's 0 minus 3. So minus 3. And we can reflect that to the other side. And then our x-intercepts we're going to find by factoring. So that means we're going to break up the x squared, and we're going to break up the 3 so that we can have a negative 2 when we check the inner and the outer. So negative 3 and positive 1. So we're going to have the point 3, 0 and the point negative 1, 0. So we go to negative 1, 0, we go to 3, 0, and we have enough to complete our graph. And for this one, we're going to be using a dotted line. And it says that we need to be greater than this y value. So if we're here at this y is at negative 4, and y values that are greater than that are found above. Now if we look at where these shadings would intersect, that's going to be where the down arrow and the up arrow meet, which is going to be in this region in between the two parabolas. And so that would be your shaded solution set.